Okay, let me see if I can get this right. This is going to be a combination video, mainly to show what the difference the right capacitance does. So this is the H.H. Scott 340B. It was broken. If you look at my other videos, you'll see. Bad bias voltage, bad DC voltage, bad everything. So what you're going to see right now is that with a new bridge in it, I'm going to show you what the voltages are on the 12AX7s. If I get this thing into the picture here. Okay, so what I have is my full wave bridge is over here. I have a positive negative lead going over here. These are taps for the 7651s. I think they are 7951s, whatever, who cares. Alpha tubes. Those are the biases for the alpha tubes. Rather than continuing just to stick a probe in there and possibly blow myself up along with it. But what's happening here is that right now there's no capacitance on this circuit. Okay, it's just a good bridge. The cap for the circuit is right here. Resistors are along the way. There's a over here. These are three 30 ohm resistors, 30 ohm 5 watt resistors. And I'll show you what the voltages read on this thing. Right now I am in AC volts. So get my glasses on. I'm going to pause this thing for a little bit so I can get a little better setup here. Okay, so what you're seeing is the voltage coming out of the bridge. So I have 48 volts coming out of the bridge, and those are just test taps that I put in there temporarily. All right, but what I'm going to do now is just flip this sucker over to AC so you can see what I got riding on here. AC volts, and I got 20 volts AC riding right off the bridge, which is actually ripple, as you know. But anyway, it doesn't really matter. Now, previous to this, what I used was about 1100 microfarads, about 1000 microfarads, about at 70 volts. And I might be wrong with that. Hold on, let me see exactly what they were. No, I'm right way, of course. Wasn't any place close to that. More like 20 microfarads. They're in series. Okay, so I got two capacitors in series at about 40 microfarads each. So half that, Ohm's law, whatever. Okay, so what I'm gonna do is I'm gonna shut this stupid thing down because I don't need anything blowing up on me, and I don't need to make a mistake at the last minute. And I'm gonna add 470 microfarads at 100 volts DC, 100 volt caps. Hold on. That's the DC voltage now with one 470 microfarad capacitor added across the bridge. That's crazy what a difference it makes. And now we're going to switch over to AC volts. Point 2. I'm going to add another 470, and that's going to drop down to nothing. Actually, right there, it may be seeing 0.2 volts ripple. My guess is that if I read this at the filament side, which will be after 100 ohms of resistance in series, it's going to read 0. So that's ripple. That's coming out of the cap, but there's no chokes. They use resistors, and I'm before them. I'm going to put this on pause again, and I'm going to move over to the filament. Okay, now I'd have to go back to my last video to see what this voltage was. But this is the voltage directly across one of the 12AX7s, 12.3. Exactly what it's supposed to be. And then let's see what the AC is. It's probably going to be a couple of millivolts rather. Yeah, it's kind of cold. 0.1, 0.2 volts. I'm going to add, the end result of this, I'm going to add another capacitor to this. That'll bring it from 470 up to 940. So let's see what that does. I guess I'm going to pull this thing down to 0. Let's see what happens. All right, I added another 470 microfarads. So that's 940 microfarads. This is right after the bridge, before the resistors. The amp is off. I'll power this amp up. I think. Tendency to keep reaching around. Let's watch what the AC voltage does now. It was 0.2 volts before. .087. Okay. Let's go over to DC. DC is probably going to read the same though. Still 12.3. That's fine. Biggest kicker is right here, is the AC. So the AC's gone for all practical purposes. I mean, if I put a choke in this, it'd go away. I'm not going to worry about it. I'm not cutting this circuit open. These are all very accessible points, so I'm going to leave it at that. Interesting thing that we're going to really find out maybe in the next video is the biasing of these tubes. These are what was broken. These are 7591s, and this particular one here was busted. The cap over there was broken. One of the resistors was broken off. That resistor right there, that's a 10 watt 20 ohm, that was shattered. Those resistors back there, they were shattered. This resistor right here was shattered. On the bias side, you see that yellow gold, orange gold, 3.3 ohms. That's the DC bias resistor. So it's been recommended to me that I change it. This is not my amp. I did not sign on to recap and change all these components. I was just trying to get it working. Right now this thing works. It works real good. It's quiet. That's volume turned all the way up. There's almost nothing coming out of that that's unreasonable. You cannot hear it for this phone, I'm sure. And I can barely hear it. So it's literally non-existent. The more the amp warms up, the quieter it gets, and I'm pretty sure when I get new tubes and I have balanced tubes, all the same, and I set the bias correctly, which will be set as per the specs, manufacturer's specs, the thing's going to be fine. I mean, for all practical purposes, this amp is done. I did let the owner know that he needs 2 new 7591s, 2 new 6U8s, And this is 100 times better than when he bought it. When he bought it, he said it sounded nice. That hum that I heard in the very first video was the way he bought it. That's after I fixed the tubes, the resistors, and even before the bridge. So it was a bad hum. He just thought it was normal, I guess. And honestly, as soon as you start pumping a little audio into this thing, you don't hear it at all. This is supposed to be, I think, 28 watts per side. I'm seeing it as about 20.5 watts. You do the math. But that's a hell of an amp, any way you want to look at it. This thing's real nice. It's a, look it up, it's a H.H. Scott 340B made in 1963. The schematic is readily available. And other than soldering in a few components, taking away a few of the test points that I put in there just for myself, I'm pretty much done. I got a little soldering to do. Just make sure I don't F it up before I give it back. Good night.